Okay, hello everyone. So today I have a sample problem for vector addition of perpendicular vectors. Let's read the problem. A river flows north with a speed of 3 miles per hour. A man rows a boat across the river. His velocity relative to the water is 4 miles per hour east. What is his velocity relative to the earth? So sketch the vectors and resultant, solve for the magnitude of the resultant vector, and solve for the angle of the resultant vector. So as you could see, I already did a few highlighting here so we can focus on the values. So a river flows north 3 miles per hour. His velocity of the boat 4 miles per hour going east. So what is the velocity relative? So if we were to imagine it, it looks something like this. This is the river. It's flowing north. The boat is trying to go east, but realistically, because it's pushing that way and the river is flowing that way, you will veer off a little bit that way. Okay, so you're going to try to find this velocity. So how do we do that? So first, let us do part A. Sketch the resultant and the vectors. Or sketch the vectors first and then the resultant. So I have my triangular ruler. So 4 miles per hour due east. So we can perfectly align this at the 4 and 3 miles per hour due north. Okay, so we're going to add those two vectors up. Let's draw the line. Okay, so we know that this one represents 4 miles per hour going east and then 3 miles per hour going north. So now that we have some final answer with our drawing, let's sketch them. Let's use a different colored marker for this. Okay, so that's your first vector, 4 miles per hour east. Then the second vector goes like that. This one is 3 miles per hour due north. Okay, so now what is the resultant vector of those two? All we have to do is connect the tail to the head. Because we've already done a tail to head situation, we can then connect the tail to the head like so. Draw a line, and there is your resultant vector. Okay, so solve for the magnitude of the resultant vector. So one way to solve for the magnitude would be to use what theorem? Pause this for a while and think. Again, it's a right triangle. That calls for the Pythagorean theorem. Okay? So by Pythagorean theorem, we can get the two sides of that right triangle, 3 and 4, and solve for r. So a squared plus b squared, and the square root of that will give you r. Okay? So what is a? Let's make this a, and let's make this b. So a is 4 miles per hour, b is 3 miles per hour, and square root of that will give you r. So if you were to add this, this would be 16 plus 9, and 16 plus 9 would actually give you the square root of 25, which will simply be 5. So r will be 5 miles per hour. And actually, without calculating, you can actually solve for 5 miles per hour by two means. So first, because you drew a right triangle, you could actually measure using your ruler. So as you could see, it's around 5 centimeters, 5 miles per hour. Another way to do it would be to use your knowledge on Pythagorean triples. So this is an example of a triple that's 3, 4, 5. So by that alone, you can get that r is equal to 5 miles per hour. Now for the harder part. What is the angle of the resultant vector? So in order to solve the angle of the resultant vector, so in this diagram over here, we're going to look for this angle like so. How do we do that? Well, we can use SOHCAHTOA. But actually, we do not need this one. We don't need that. We only need TOA. TOA stands for tangent equals opposite over adjacent. Okay, so that means that the tangent of theta, tan of the angle, is equal to the opposite side over the adjacent side. And when we tinker with this further, we can actually simplify this to tangent inverse of opposite over adjacent is going to be the exact value of your angle. Okay, so let's plug in the values. So tangent inverse, let's start from scratch over here. Tangent inverse of opposite. So what is the opposite side? Well, the opposite side to the angle is the one right here. So that's 3. Adjacent side, so the one adjacent will be the one below. That's 4. Tangent inverse of 3/4 will give you theta. Now, if I get my calculator real quick, we can actually solve for the value. So to get tangent inverse, we just go shift tangent inverse of 3 over 4. Okay, so when I press the equal sign like so, that should give me the angle 36.86 degrees. So that's around 86 degrees. And that's my final answer. That's my angle. Theta 36.87 degrees. Okay, so when you're faced with a problem like this, first you sketch the vectors and the resultant. Just the right triangle. Tip to tail or tail to head, make the resultant. And then to calculate the values, if it's not a Pythagorean triple, you can use the Pythagorean theorem. Okay? Alternatively, if you really do not know how to solve, I hope you don't forget the Pythagorean theorem, but one way to get the answer is to just draw it proportionally. So if you draw this 4 cm and this 3 cm, when you put your ruler in, your resultant should be 5 cm. And then to get the angle, you use SOHCAHTOA. Tangent is equal to opposite over adjacent. That's all you need to know. You don't need SOH and KA, you only need TOA. And when you plug in the values, remember, tangent inverse of opposite over adjacent. That's your angle. Okay, so I hope this video enlightened you with how to solve for resultant vectors mathematically. And I wish you luck in our problems and exercises ahead. Take care.